Hello children, I am Ekta. Welcome to the captivating realm of circles. Have you ever noticed the perfectly round shape of a wheel or the outline of a coin? These everyday examples are instances of circles, which are fascinating geometric figures. In this lesson, we will explore the characteristics and properties of circles, unraveling their secrets and understanding their significance. In this lesson, we will learn about the center and radius of a circle. The center acts as a fixed point, while the radius represents the distance between any point on the circle and the center. We will also discover the concept of chords, which are line segments connecting two points on the circle's boundary. Additionally, we will explore the diameter, which is twice the length of the radius, and the circumference, which measures the length of the circle's boundary. Get ready to uncover the wonders of circles and their practical applications. Learning outcomes. Understand the key elements of a circle, including the center, radius, diameter, and circumference. Recognize the properties of tangents and secants in relation to circles. Apply theorems regarding tangents, secants, and the length of chords. Solve geometric problems involving circles, such as finding the radius or length of a tangent. Keywords: circle, center, radius, chord, diameter, circumference, arc, sector. A figure made by all the points which are at the same distance from a fixed point is called a circle. Center. The fixed point is known as the center of the circle. Radius. The distance from any point on the circle to the fixed point is the radius. Any line segment which joins the center and any point on the circle is known as the radius. Chord. Any line segment made by joining any two points on the boundary of the circle is called chord. Diameter. Diameter is 2 times the radius. It is the longest chord on the circle which passes through the center. All the diameters have the same length. Circumference. The length of the boundary of the circle is called the circumference of the circle. Arc. An arc is the part of the circle joining 2 points on the circumference of the circle. Sector. An area made by an arc and 2 radii of the circle by joining the center to the end points of the arc is called sector. Segment. An area made by a chord and the arc of the circle is called a segment. Circle and line in a plane. For a circle and a line on a plane, there can be 3 possibilities. They can be non-intersecting. They can have a single common point. In this case, the line touches the circle. They can have 2 common points. In this case, the line cuts the circle. Tangent. A tangent to a circle is a line that touches the circle at exactly one point. For every point on the circle, there is a unique tangent passing through it. Secant. A secant to a circle is a line that has 2 points in common with the circle. It cuts the circle at 2 points, forming a chord of the circle. Tangent as a special case of secant. The tangent to a circle can be seen as a special case of the secant when the 2 endpoints of its corresponding chord coincide. Two parallel tangents at most for a given secant. For every given secant of a circle, There are exactly two tangents which are parallel to it and touch the circle at two diametrically opposite points. From the given diagram, we can observe the following points. PQ is the secant of a circle. P dash Q dash and P double dash Q double dash are two tangents that are parallel to PQ. Theorem. The theorem states that the tangent to the circle at any point is perpendicular to the radius of the circle that passes through the point of contact. Here, O is the center and OP perpendicular to XY. Theorem proof. Assume a circle with center O and XY being tangent to the circle at point P. Now, we have to prove that OP is perpendicular to the tangent XY. Now, consider a point Q on the tangent line XY other than P. Join the points OQ as shown in the figure. Here, point Q should lie outside the circle because if the point Q lies inside the circle, XY will not be a tangent to the circle. It means that XY will become a secant of a circle. So, OQ should be greater than the radius of the circle OP. It means that OQ greater than OP. As this condition is obeyed for all points on line XY except P, OP should be the shortest of all distances from the center of the circle O to the points of line XY. OP is perpendicular to XY. Hence, the theorem is proved. Example. Find the radius of the circle in the given figure. If the length of the tangent from point A, which is 5 cm, away from center is 4 cm. Solution. As we know that the radius is perpendicular to the tangent, so the triangle ABO is a right angle triangle. Given AO is equal to 5 cm and AB is equal to 4 cm. We can use Pythagoras theorem here. OA square is equal to OB square plus AB square. OB square is equal to OA square minus AB square. Substitute the values we get is equal to 5 square minus 4 square. 25 minus 16. OB square is equal to 9. OB is equal to 3. So, the radius of the given circle is 3 cm. The number of tangents drawn from a given point. If the point is in an interior region of the circle, any line through that point will be a secant. So, no tangent can be drawn to a circle that passes through a point that lies inside it. When a point of tangency lies on the circle, there is exactly one tangent to a circle that passes through it. When the point lies outside of the circle, there are accurately two tangents to a circle through it. The length of the tangent from the point, say P, to the circle is defined as the segment of the tangent from the external point P to the point of tangency I with the circle. In this case, Pi is the tangent length. Theorem. The length of tangent drawn from an external point to a circle are equal. Proof. Assume that we are provided with a circle whose center is O and P is the point that lies outside the circle. The two tangents formed here are PQ and PR on the circle from the point P as shown in the figure. Now, we have to prove PQ is equal to PR. To prove this, we have to join OP, OQ and OR. According to the theorem, the tangent to the circle at any point is perpendicular to the radius of the circle that passes through the point of contact. The angles formed between the tangents and radii are right angles. So, two right angles are formed, such as angle OQP and angle ORP. Thus, from the radii of the same circle, we can write OQ is equal to OR. Common side. OP is equal to OP. Hence, using the RHS congruence rule, triangle OQP congruence to triangle ORP. Thus, it gives PQ is equal to PR using CPCT. Hence, the theorem is proved. Let us see one example. Find the length of AB in the given circle, which is the chord in the outer circle and tangent to the inner circle. The radius of the inner and outer circle is 6 cm and 10 cm respectively. Solution. Given radius of the inner circle R is equal to 6 cm. Radius of the outer circle R is equal to 10 cm. As point T, which is the tangent point, is the midpoint of the chord, AT is equal to TB, as the radius is perpendicular to the tangent. So, is a right angle triangle and we can use Pythagoras theorem. OB square is equal to OT square plus TB square. TB square is equal to OB square minus OT square. Substitute the value we get is equal to 10 square minus 6 square. We get is equal to 100 minus 36. So, here we get TB square is equal to 64. Therefore, TB is equal to 8 cm. Now, we can find AB. So, AB is equal to TB plus AT. Substitute the value we get. AB is equal to 8 plus 8, AT is equal to BT. Therefore, AB is equal to 16 cm. Points to remember. Circle. A figure formed by points equidistant from a fixed point. Tangent. A line that touches the circle at a single point. Secant. A line that intersects the circle at 2 points, forming a chord. Theorem. Tangents are perpendicular to radii at the point of contact. The length of tangents from an external point to a circle are equal. Thanks for watching. Like, share and subscribe.